Maths Mocks 2022, Paper 2. If you like what you see, please subscribe to the Tulamaths YouTube channel by clicking subscribe down the bottom right hand corner. Question 1. In the diagram OABC is the trapezium with OA parallel to CB. The coordinates of O, A and B are as shown in the diagram. So part A, calculate the length of the line from O to A. So they're looking basically for us to calculate the length of this line here. Now O is the origin, which would have the coordinates of 0, 0. So option 1 would be to use the distance formula to get the distance from O to A, or else we can use our knowledge of Pythagoras' theorem, so we could make a triangle out of this and calculate the length of the side using Pythagoras' theorem, because we know that the height of this triangle would be 1 and the width of it here would also be 1, and I've created a 90-degree triangle. So we're basically looking for the hypotenuse of this triangle. So that's the method I'm going to use. So our Pythagoras theorem is given as c squared is equal to a squared plus b squared. C would be my hypotenuse, which I've called as x, and my height would be 1, or my adjacent, and my other side would also be 1. So I would have x squared is equal to 1 plus 1, x squared is equal to 2, so therefore x would equal to the square root of 2. So that's the side OA. It has a length of square root of 2 units. Now, like I said, you could also use the distance formula from 0, 0 to minus 1, 1. Part B is very similar. We can have two methods of doing it. We could use the triangle that we've already sketched and use rise over run. So this would be my rise and this would be my run. So that would give me slope equals rise over run, which is equal to 1 over 1, which is 1. Now you can see though that the slope from A to the origin is going down, so it'd be a negative slope. So therefore my slope would be minus 1. So that's one way of doing it. Now you could also use your formula for y2 minus y1 over x2 minus x1 equals slope. Use the coordinates minus 1, 1 and 0, 0. And if you sub them in using x1, y1, x2, y2, you'll also get your slope to be negative 1. So it's up to you which method you take. Okay, next part of that question is asking us to find the size of the angle OAC. So if I come back up to my triangle here for a second, the method I'm going to take to this is I'm going to find out the size of the angle marked in purple first. And then what I'm going to do is I'm going to find the angle in green, which is OAC, by taking away the purple one from 180, because we know that the two angles here must add up to 180. So that's the approach I'm going to take to this. So first thing I'm going to do is I'm going to examine this triangle here that I'm marking in green. So I'm just drawing it out. And we have a 90 degree here, and we know that the two sides are 1 and 1. And from the information I'm given, I also know that the root 2 is from part A. And I'm going to find out the size of this angle here, and I'm going to call it angle A. And in order to find the size of angle A, I'm going to use either one of my sine, cos or tan ratios. And I'm going to use the tan because I already have a lot of the information from it. It's the inverse of the minus 1, but let's do it out. So tan angle is opposite over A, adjacent, which would give me tan angle is equal to opposite, which is 1 over 1. Moving over, my tan would give me a tan inverse of 1. And the tan inverse of 1 is 45 degrees. So the angle A, let's just mark it on my picture, is 45 degrees. That's not the angle I want. The angle I want is angle AOC, which is in here. But like I said, to get the size of that angle, we just need to take 45 away from 180 degrees. So therefore, my final solution is 180 minus 45 degrees, which is 135 degrees. So that's the size of the angle AOC. Now, if you want to go in degrees, if you're working, or sorry, in radians, that would be the same as 3 pi over 4. So again, just make sure you have your calculator set either with the little D to note degrees or R for radians. Part C, find the equation of the line segment BC and hence or otherwise find the coordinates of C. So BC, what do we know about BC? So we know the slope of BC is the same as slope of a origin. So we know that those two lines are parallel. So the slope there is -1. So that's the first thing we know. Now we can find the equation of the line by just using that slope and one of the points. And we know the slope, or the point B, that sits on the line BC. So I'm going to use that to form my equation of the line. So I'm using B, 4, 6, and I'm using slope -1 because it's parallel to BC. Or sorry, AO I should say. Forming my equation of the line, y minus y1 is equal to m times x minus x1. Subbing that in, y minus my x1 and y1, so I'm subbing in my y1, which would be 6, equals my m, which is -1, times x minus x1, which is 4. And then just tidying that up a little bit, I'm going to multiply in the brackets. I get y minus 6 is equal to -1x plus 4. And moving everything to the left-hand side, that's leaving me with positive 1x plus positive y minus 6 minus 4 is equal to 0. So the equation of the line is x plus y minus 10 is equal to 0. Now it's asking me to find the coordinates of C, but we know the coordinates of C to a certain extent. It's on the x-axis, so we know that the y has to be 0, but we don't know the x part of it. So we're going out some distance on the x-axis, but we're not going up or down on the y, so that's why it's 0. And if we want to verify a point is on a line, we basically sub it into the equation of the line. So I'm taking the equation of the line that we have, and I'm basically going to sub in the coordinates of C. Now, I don't know what the x are, so I'm just leaving it as x, 1x, plus my y, which we do know, it's 0. So this is my x and this is my y. And I'm subtracting 10 is equal to 0. So I have 1x plus 0 minus 10 is equal to 0. So 1x minus 10 is equal to 0. Moving over the minus 10 or adding 10 to both sides, I get 1x is equal to 10. So therefore x is equal to positive 10. So the coordinates of C are 10, 0. Now looking at part D, show that the perpendicular distance from the point O to the line BC is 5 root 2. So O is the origin, which has the coordinates of 0, 0. And BC is the equation of the line which we just found, which is x plus y minus 10 is equal to 0. Perpendicular distance formula for my log tables is given as the modulus of A times x1 plus B times y1 plus C all over square root of a squared plus b squared. So that's coming from my log tables. The a is the number in front of the x, so a is equal to 1. The b is the value in front of the y, so b is equal to 1 as well. And c is the constant, which is minus 10. x1 is 0, y1 is 0. So filling in my formula now, the perpendicular distance, or the length from B to C to the origin, is going to be the modulus of A, which is 1, times x1, which is 0, plus B, which is 1, times y1, which is also 0, plus my C, which is negative 10, all over the square root of A, which is 1 squared, plus B squared, which is 1 squared. 1 times 0 is 0. 1 times 0 is 0 again, minus 10 over the square root of 1 squared is 1, 1 squared is 1. So 0 plus 0 is 0, take away 10, so that's minus 10 modulus over the square root of 2. Those modulus brackets mean I turn my answer into a positive, so that's giving me 10 over the square root of 2. And when I type in 10 over the square root of 2 on my calculator, I get a perpendicular distance of 5 root 2 units. And that's what they asked in the question, to show that the distance from the origin to the line BC is 5 root 2. And part D then, hence or otherwise, calculate the area of the trapezium origin A, B, C. So first thing I'm going to do is perhaps sketch out that shape. Okay, so not a work of art, but just to visualize what we're looking at here. So we've A, origin, the distance there is √2. I have B and to C, and I have that as a distance of O to C, and then I have B. We've found from part D that the perpendicular distance from the origin to BC, so the shortest distance, so I've just drawn a dotted line to represent that, 90-degree angle created here, as 5√2. The formula for the area of a trapezium from my log tables is given as A plus B over 2 times the h, the perpendicular height. So if I look at my picture, my A is √2, my B is unknown, that's the length from B to C. Now I'll find that in a couple of minutes, and my h is the perpendicular height, which is 5√2. So I'm nearly there with the information, I just need one last little bit. So let's go off and find the distance or the length BC. And I know the coordinates, they're 4, 6, and 10, 0. And I'm going to label them x1, y1, x2, y2, and I'm then going to use my distance formula for my log tables to calculate the distance between those two coordinates. So from my logs, distance is equal to x2 minus x1 all to be squared plus y2 minus y1 all to be squared in a square root. Filling that in, I have 10 subtract 4 to be squared plus 0 minus 6 to be squared. 10 take away 4 is 6 squared plus negative 6 squared. Just be careful here if you're using your calculator, just make sure you use brackets when you're squaring a negative. So that's giving me the square root of 36 plus 36, which is a distance of square root of 72. If you want to go in third form, it comes out to 6√2. So filling that now on my picture, I have 6√2 as the base of my shape. And I'm now going to come back over and fill in my formula now of the trapezium. So area of trapezium is equal to A, which is now √2, plus B, which is 6√2, all divided by 2, multiplied by H, which is 5√2. And if I add what's in the brackets, I get √2 plus 6√2, that gives me 7√2s over 2, multiplied by 5√2. Which is going to give me an area of, well, multiplying 5 by 7, I get 35. √2 by √2 gives me 2. Again, this is calculator if you want, I'm just doing them in my head. Cancel out those 2's. So that's giving me an area of the trapezium of 35 square units. Okay, and that's the end of question 1. Question 2a, a circle has a centre C and the endpoints of a diameter of the circle are A and B. Find the value of K, where K is not equal to 0. First thing I'm going to do here is I'm going to sketch my circle C, and I have my centre point of C, which is 1, 3, and the diameter and the endpoints of the diameter are my A and my B, -3, 2K, and my B, which is 5K. Now, in order to find the value of K here, I'm going to use the midpoint between my A and my B, and the midpoint is the center of my circle, which is C. So from my log tables, the midpoint formula is given as x1 plus x2 divided by 2, comma y1 plus y2 over 2. Going to my points A and B, x1, y1, x2 and y2. Just make sure and label up your coordinates. So my center is my midpoint. So my midpoint here will be 1, 3 is equal to x1 plus x2, which is -3 plus 5 divided by 2, comma k plus 2k. Tidying that up, I get 1, comma 3 is equal to 2 over 2, comma 3k over 2. So what does that give me? That gives me my center, 1, 3, is equal to 2 divided by 2, which is 1, comma, 3k over 2. Now you can hopefully see that the x is my 1, and that's equal to 1, so that's verified, that's true. Now I'm looking for the y part of my coordinate, which is 3, but I have it as 3k over 2. So I just need to figure out what I need to sub in there for k to multiply by 3 and divide by 2 to get 3. So therefore, 3 must equal to 3k over 2. Get your common denominator of 2 or cross multiply, which will give me 6 equals 3k. So dividing across by 3 will get me the value of k, which is 2. Okay, that's part 1 done, the value of k. Part 2, hence find the equation of the circle. So my formula for the equation of a circle is x minus h squared plus y minus k squared equals r squared. So that's from my log tables. I know my center, that's my c, so my hk is equal to 1, 3. Next thing I need to do is go off and find the radius. And the radius is found by finding the distance from either c to a or c to b. I'm going to find the distance from c to b. I know the k, I can sub that in now. So that value for k I found in part I to be 2. So the coordinate for b is 5, 2. So I'm getting the distance, as I said, from the center, which is 1, 3, to the coordinate of b, which I have as 5, 2. Now, like I said, you can find the distance from c to a. So labeling my coordinate, x1, y1, x2, y2. I'm using the distance formula now from my log tables, and the distance formula x2 minus x1 squared plus y2 minus y1 squared, all in the square root. So distance is equal to square root of x2, which is 5 take away 1, all to be squared, plus y2 take away y1, and that is giving me 5 take away 1 is 4, so my distance is equal to square root of 4 squared, and 2 take away 3 is minus 1, so plus minus 1 squared. Just make sure you're using your calculator now to do minus 1 squared if you're not too sure. Minus by minus will give me a plus, so it's 16 plus 1, which is the square root of 17. So my distance, or my radius in other words, is the square root of 17. And now I'm going to put that back all into my equation of the circle. So therefore, my equation of the circle is x minus h, which is 1 squared, plus y minus k, which is 3 squared, equals the square root of 17, all to be squared. So no need to multiply out the left-hand side of the equal sign. So x minus 1 squared plus y minus 3 squared, but the square root of 17 squared is 17. And that's the equation of my circle. Find the length of the tangent from the point P to the circle. So our circle with the center C, let's just sketch out what we have here. And our center C is 1, 3. And we have this random point P outside of the circle. And it's a tangent, so it's touching the circle at exactly 1 point. And we know that the rule for when the radius touches the tangent, it creates a 90-degree angle when it hits the tangent. And in order to find the length of this tangent, so let's call it x, the distance from the point P to where it touches the circle here, I'm going to make a triangle out of it, and the triangle is going to then connect P to the center. And I'm going to find that distance because we're given the coordinate 7, 6. So if I find the distance from 7, 6 to the center 1, 3, I can then use Pythagoras' theorem to calculate the length of x. So first thing, as I said, find the distance from the center to the point P. So I have 1, 3 as my center and 7, 6 as my P. So that's x1, y1, x2, y2. Using my distance formula, x2 minus x1 all to be squared, plus y2 minus y1 all to be squared in the square root. So that's my distance formula. And that is giving me the square root of 7 take away 1 to be squared, plus 6 take away 3 to be squared. And that's giving me 6 squared, which is 36, plus 3 squared, which is 9, which is a distance from the center to the point P of the square root of 45 units. So marking that onto my picture here. And now I'm going to use my Pythagoras theorem formula, which is c squared is equal to a squared plus b squared. I'm going to call the side opposite the 90 my c. So I always have to call the side across from my 90 my c. And my other two sides a and b. So I'm going to call this side I want a, and the other side my radius, which is b. And I know my radius, it's the square root of 17. We got that in the previous part of this question. So filling in my Pythagoras theorem now, I have c squared, which is square root of 45 to be squared. A, which is my x, the value I'm looking to find, the length of the tangent, plus my b, which is my square root of 17 squared. That's my radius. Square root cancels with the square, so that's 45 is equal to x squared plus 17. Taking 17 from both sides, or moving over that 17, will give me 45. Take 17 is equal to x squared. So x squared is equal to 45 take 17 is 28. And to get x on its own, I'm getting the square root of both sides, which is the square root of 28, which is the same as 2 root 7. So that's my length of the tangent. Okay, that is part 3, and now we're going to do the final part B. Find the equations of the two circles which touch both axes, which contain the point 4, 8, and whose centers lie in the first quadrant. So the first quadrant is the positive quadrant, top right hand corner of our graph. And I'm just going to show the graph. I'm actually going to show you the circles before we actually get into the question, just so you can visualize what it's asking us to do. So both circles touch the point 4, 8. So I've just sketched that there on my graph. So that's the point there. I've labeled it as A. And it then tells us that the circles touch both axes. So I'm going to put up the first one here, and you can hopefully see it in a little bit more detail. So the first circle is drawn there. And because it touches both axes, it basically means that the center of that circle is 4 across and 4 up. Because again, it touches that point A, which is 4, 8. So half of 8 is 4. So what we're going to have to realize here when we answer this question is that the radius is the same distance as what I go across on the x-axis and up on the y-axis. So my point I'm going to call maybe or in a second, because that's the same as my radius. If we sketch the other circle, so let's just sketch the other circle here. It's quite a large circle, so I'm just going to zoom out here so you can see it. Again, it touches both the x-axis and the y-axis. It contains that point 4, 8. And you should be able to realize, look where it goes up on the y-axis, it goes up 40 and it comes out 20. So again, my radius there would be 20, up 20 to get to the center. So the center there would be 20, 20. So again, my radius or, my center or. So that's the information we're going to use to answer this question now. So the first thing I'm going to do here is take down the equation of my circle from my log tables, x minus h to be squared plus y minus k to be squared equals or squared. And from what we've just explained, I'm going to give my center a name, and I'm going to give my center the point or, because it is the same as my radius. And I'm going to give my radius a name, I'm going to give it the name or. So if I come out 20, I go up 20, same as my radius. If I come out 4, I come up 4, same as my radius. Now we need to basically find those answers 4 and 20 that we just seen on our GeoGebra. So what does that mean? So let's fill in my radius. My radius is my radius and my center point. My center point is HK and or is my radius. So filling that in, I get x minus h, which is x minus or to be squared, plus y minus or to be squared equals or squared. Simple as that. I'm just subbing in or as my center point. It then tells us that the point 4, 8 sits on the circle. And if the point sits on a circle or on a curve, I can basically sub that in. for x and y. So it must verify the circle. So if I sub that in, it should satisfy it. It should equal to 0 basically. So that's all I'm going to do. I'm going to take my equation of the circle now, and I'm going to sub in 4 for x and 8 for y, because that's my coordinate which sits on the circle. So I'm subbing in 4 for x and 4 minus r all to be squared, plus my y, which is 8, minus r all to be squared, equals r squared. And I'm going to square out those brackets. So a square means I multiply the bracket by itself, and then I'm going plus 8 minus r to be squared, so 8 minus r by 8 minus r equals r squared. And tidying that up, I get first term by second bracket, second term by second bracket, then I'm on to the 8 minus r, so 8 times 8 minus r times my second bracket. And that's all equal to r squared. Tidying it up, let's see what we get. So I'm going to multiply in this one first. I'm getting 16 minus 4r. Multiplying in the second one, I get minus 4r plus r squared. Then multiplying in the 8 into the 8, I get 64 minus 8r. And then finally, I multiply in the minus r, and I get minus 8r plus r squared equals r squared. I'm going to move over that r squared, or subtract r squared from both sides, and tidy everything up there a little bit. And I'm going to get, so let's see, I'll have this r squared is 2r squared, take away r squared will give me 1r squared. I'll have minus 4 minus 8 gets me to negative 24r. And then I'll have my constant 16, 64, that's getting me to 80. Positive 80 equals to 0. And I'm going to factorize that. So two brackets, guide number minus b formula, whichever suits. I'm looking for the multiples to get to 80, and which must add to negative 24. So I'm getting 20 multiplied by 4, because 20 plus 4 is 24, and two negatives. Minus by minus is plus. So that means r is equal to 20, r is equal to 4. And that's what I had on my picture a few minutes ago. Now we have to find the equations of the circles. So I have my two equations. So first equation of circle, and I know my formula, it's x minus h. So I'm going to sub in my h in a second. So I'll just write it out actually again. Y minus k all to be squared equals r squared. And like we said, r is my center, r is my radius. So I'm first circle, I'm subbing in 20, x minus 20 to be squared, plus y minus 20 to be squared equals 20 squared. And always square out your radius. There's no need to multiply out the brackets. And that's getting 400. So that's my first equation. My second equation of the circle is going to use the 4 this time. So it's going to be x minus 4 to be squared plus y minus 4 to be squared equals 4 squared, which is giving me x minus 4 squared plus y minus 4 squared equals to 16. Question 3a, Ron telephones his mother, who is self-isolating due to an outbreak of COVID-19. If her telephone is engaged, he tries again until he is successful, or until he has made 3 unsuccessful attempts. At any attempt, the probability of the call being successful is 0.7. Part 1, find the probability that Ron will be successful on the second attempt. So basically what that means is, on the first attempt, he's going to fail, he's going to be unsuccessful, and then on the second attempt, he's going to be successful. So that's what we're looking for the probability of. So the probability of failing to get through is 1 minus the 0.7. So failure is 0.3. So my answer here is going to be the probability of failing, 0.3, and that means to multiply the probability of success, which is 0.7, and multiplying 0.3 by 0.7 gets me 0.21. So the probability of Ron getting through on the second attempt is 0.21. Part 2. Find the probability that Ron will be successful on the third attempt. So once again, that means he's going to fail on the first attempt, fail on the second attempt, and be successful then on the third attempt. So that's giving me a probability of failure of 0.3 for the first, and again means to multiply probability of failure for the second and probability of success for the third. So 0.3 by 0.3 by 0.7 is 0.063. So 0.063 is the probability of getting through on the third attempt. Part 3. Find the probability that Ron will be successful in telephoning his mother. So there's different scenarios there. He could get through on the third attempt, which is fail, fail, success. Or it could be he could success on the first attempt, which means he doesn't need to ring again. So I don't need to do success, fail, fail, because once he gets through, he's happy. And he could also fail on the first and succeed on the succeed on the second. So once again, we don't need to worry about the third call there because he's successful on the second. So how would that look using probability? Well, for fail, fail, success, we have that from part 2. It's 0.063. Or in maths means to add in probability. So I'm adding on the probability of success on the first call, and that's given to me in the question. That's 0.7. Or successful on the second call, so fail on the first and successful on the second. Well, that's my answer to part 1, which was 0.21. So adding those three probabilities together, I get 0.973. And that's part A done. Part B is talking about the coin, so it's separate altogether. So looking at B part 1, if 3 coins are tossed, find the probability of getting 2 tails and 1 head. So we're going to look at this in 2 ways. We're going to do it just the old-fashioned way, listing out the possible orders we could have, and then I'm going to use my binomial distribution on page 33 of the log tables. So one option could be a tail followed by a tail followed from a head. I could have a tail, head, tail, or I could have a head, tail, tail. All 3 of those options are giving me 2 tails followed by a head in any order. The probability of getting a tail is 0.5, another tail 0.5, and a head is 0.5. I'm flipping a coin. There's only the 2 options. And that's the same for all 3. And it's one or the other. An or in maths in probability means to add. So when I multiply these, first of all, I get 1 out of 8, and I add them together, which is giving me a total probability of 3 out of 8. So the probability of getting 2 tails and 1 head is 3 out of 8. The second way of doing it, as I said, is by using the binomial distribution on page 33 in the logs, which is given as n choose or times p to the power of or times q to the power of n minus or. This is used when you have 2 possible outcomes, success or failure. So my n stands for the number of trials, that's my 3, and I'm choosing or the probability of success, which is going to be 2. The probability of success, that's getting a tail, that's a half, 0.5, to the power of or, which is my 2, because I want it to happen twice. And failure then is my head, 0.5, n minus or, which is 3, take 2, which is 1. So that's my 1 head. And when I type that on my calculator, I'm getting the same answer, 3 over 8. Looking at part 2. If 3 coins are tossed 8 times, find the probability of getting 2 tails and 1 head exactly 3 times. Give your answer to 4 decimal points. So I'm going to answer it in the same way. I'm going to use page 33, the binomial distribution, and we'll write it down again. N choose or, p to the power of or, which is success, and q is my failure, n to the power, or n minus or is my power. So number of trials here is 8. I'm doing it 8 times, and I want to succeed 3 times. I want to get 2 tails and 1 head exactly 3 times. Now the probability of success, well, first of all we have to figure out, well, what is success? Success happens when I get 2 tails and 1 head. But I have that answer from part B up above, when I found the probability of getting 2 heads and a tail. So my P here is 3/8. That's the probability of what I want. And it's to the power of or, that's going to be to the power of 3. I want it to happen 3 times. My Q then is the probability of failure, not getting 2 tails and 1 head. So that's going to be the opposite of 3 over 8. So 1 take away 3 over 8 is 5/8. And I'm putting that then to 5 because I'm carrying out this experiment 8 times, and 3 of them I need to succeed and 5 of them I need to fail. So I'm using my choose button on my calculator, which is the NCR, and when I do out this calculation, I'm getting 0.2816, and the question asked to 4 decimal points. And that's the end of question 3. Question 4. A familiar question among professional tennis players is whether the speed of a tennis serve in kilometers per hour depends on the height of the player. The height of 20 tennis players and the average speed of their serves were recorded during a recent tournament. The results are shown in the table below. Part A. Plot the points from the table on the grid above. So our first point is 1.83 meters and a speed of 210. So 1.83 is going to be between the 1.8 and the 1.84. You're going up to 210 and you're putting a dot on it. The next point I'm plotting is 1.9 up to 225. So 1.9 to 225 would bring me around here. So that's all our points plotted. At this stage, just make sure you've included every point. So there's 20 people were surveyed and I have 20 green dots. Part B to that question wants us to draw the line of best fit. For drawing your line of best fit, just make sure that the line goes through roughly half of the points above the line, half of the points below the line. It doesn't have to go through the origin here. It doesn't have to go through the intersection of 1.8 and 200. So that's a common mistake that people make. So that's my line of best fit in red. Looking now at part C to this question, it wants us to find the equation of the line of best fit. So in order to do that, I'm going to use my calculator to find the line of best fit. So I'm using the Casio calculator, the new FX83 GTX calculator, and I've just listed out the steps here on the left hand side. So first of all, make sure you reset your calculator by pressing the shift button, then the 9, and then follow the online instructions. Once you've reset your calculator, you want to press the menu key, which is top right hand corner. Then you press 2, and you should see 4 options coming up. We want to click on number 2, which says y is equal to a plus bx. When you press on 2, your table should appear with an x column and a y column. You input all of your data into that table, but just make sure as you input it, you have to press equals in order to move down to the next line. Once you have the heights in the x column and the speed in the y column, press the AC button, the yellow button on your calculator. You then want to retrieve the data, so you press the option button, which is the top left underneath the shift key. When you press that, you're pressing the 3 button for regression, and up comes y is equal to a plus bx. And you basically just read the equation of the line from your calculator. And the equation of the line that I'm getting is y is equal to 157.22, that's my a, and then it's minus 70x. Again, you don't have to use the calculator for this. You can use points from the graph and use your equation of the line from the log tables, but I think the calculator is a little bit easier. Part D, explain why, in the context of this question, the y-intercept of the line of best fit is not valid. So basically what that means is, why is my line of best fit not cutting through the y-axis? Now, just to kind of remember it here, I think our graph goes to 1.8 meters, but if you were to think of our x and y-axis like this, our graph is starting here at 1.82, and they want us to see, why does our line of best fit not cross here at the y-axis? And the reason for that is that anywhere to the left of the y-axis, this direction here, is going to bring me into negative values, so negative heights in other words. And if you think about it, we can't have a negative height for our tennis player. So that's the reason why the line of best fit will not cross the y-axis. So I'm just going to state left of the y-axis, or in other words, the y Y-intercept is negative. So everything to the left of the y-axis is going to give me a negative height. And height can only be a positive value. So we're not accepting the negative values. Part E, calculate the correlation coefficient. Give your answer to correct to 4 decimal places. So once again, it's handy now to use your calculator for finding the correlation coefficient. We have all the data put on our calculator from part B and C of the question. So all we need to do now is just retrieve the correlation coefficient. And to do that, you should still see the statistics mode on your calculator. So all you have to do is press the Option key once again on your calculator, top left-hand corner underneath the Shift button. When you press the Option key, you need to press the arrow down, the little 4 arrows in the center of your calculator. Press the arrow down and you're looking for number 4, which says regression. When you click on number 4, you're looking for the OR, and it's the third key on your calculator. OR stands for correlation coefficient. So when you press 3, up comes the OR, but you have to click on the equals in order to retrieve your answer. And the correlation coefficient for this question is coming up as 0.6048, and the question wants it to 4 decimal places. Part F, what does the data suggest about the speed of the serve and the height of the server? So 0.6 is basically a mild or moderate correlation coefficient. So 1 is perfect, that's the strongest. So 0.6 is just over halfway from 0 to 1. So I'm going to say there's a mild or moderate correlation. Now, I'm going to state a positive correlation. So your correlation coefficient goes from -1 to 0 and then 0 to 1. So I'm on the positive end of my correlation. So I'm going to say a moderate positive correlation. And we need to make, in context of the question, so correlation or link, you could say, that's basically what we're trying to do here, a link between the speed of the serve and the height of the player. I think that's sufficient. So we've stated that it's moderate, it's positive, and we've contextualized it to the question. Part G, find the standard deviation of the speed of the serves in kilometers per hour, correct to 3 decimal places. So once again, we have all this data on our calculator. We've inputted the table. So all I need to do is go to my calculator again, click on the Option key, then click on number 2, and then use the arrow key on your calculator. We need to scroll down, and we're looking for the standard deviation symbol with the Y attached to it. So our standard deviation for part G would be, from my calculator, 10.902 kilometers per hour. The question wants it to 3 decimal places. Question 5. O is the center of the circle of radius 2. BC is 3.82 as shown on the diagram. Part A. Given that the angle OAB, so that's talking about A, is 42 degrees, find AB. So they're getting us to find the length of AB, correct to 2 decimal places. Let's fill in everything we know on our picture here before we go any further. So they've given us OAB. So let's just mark that in on our picture, OAB, which is this angle here. And they've told us it's 42 degrees. They want us to find the length from A to B, so that's this length here. They want us to calculate the length of that line. The question also tells us that the center of the circle is O, so the radius is 2 centimeters. So that means that this line here, coming from the center to the edge, is the same as this line here, from the center to B. So that's making an isosceles triangle, and an isosceles triangle is a triangle which has 2 sides the same length, these 2 here. So I can also mark in a 2 centimeters on this side of the triangle, but it also means the two opposite angles are equal. So that means that this angle in here is also 42 degrees. Now, the question again wants us to find the length from A to B. So I'm just going to call that X, this side here, the side that I want to find. So you can use your sine rule or your cosine rule here. I'm going to use my sine rule for my log tables, which is given as A over sine A is equal to B over sine B. Labeling the diagram here, I have X as the side that I want. So I'm going to call that, let's go with A. It then must be opposite the angle A, so I'll go with this angle here. But we can figure out the size of that angle actually, because the three angles in a triangle must add to 180. So if I subtract the 42 and the 42 from the 180, I'll get that angle, which is 96 degrees. So that angle I'm going to mark in as 96 degrees. So filling in my sine rule, I'll have A, which is X, the side I want, over my sine of 96. I then let that equal to any of the other sides. They're both the same here in this case, so I'm just going to go B as 2, and then angle B is opposite it, which is 42 degrees. Don't get stressed about the letters in the formula and the letters in the picture. Don't get them mixed up. So that's 2 over sine of 42 degrees. I'm going to cross multiply here because I have fraction equals to fraction. So that's giving me X times sine of 42 degrees is equal to 2 times sine of 96 degrees. I want X on its own, so I'm going to divide across by sine of 42. So that's giving me X, which is the side AB. That's what I'm trying to find. And when I work that out on my calculator, just make sure your calculator is in degrees mode. And you should get 2.97 centimeters. The question wants it to 2 decimal places, so 2.97. Part B, find the angle OBC. OBC. So OBC is this angle in here, this small little angle. That's the angle they want us to find. In order to find that angle, I'm going to create a new triangle, and I'm going to call it OBC. So I'm connecting O to the point on the circle C. Now I've still made an isosceles triangle because this is also my radius, which is 2 centimeters. So I have a triangle now where I know the 3 sides and I need to find the size of the angle. So for that, I'm going to use my cosine rule for my log tables, which is given as A squared is equal to B squared plus C squared minus 2BC cos of A. Labeling my picture, I will have my angle A as the one I need to find. So that has to be my capital A. The small a is the side across from it, which is this side here. So filling in my formula, they're the two you have to get right. So that's going to be 2 squared is equal to, and then my cos A, which is the angle that I need to find here. So I'll just call it A. The B and the C then are the other 2 sides. It doesn't matter which they are. So it'll be the 2, I'll call B, and 3.82 as my C. So that's going to equal to 2 squared plus 3.82 squared minus 2 times 2 times my 3.82. So again, that's using my cosine rule from my log tables. Working this out, 2 squared becomes 4, 2 squared becomes 4, 3.82 squared is 14.5924, minus 2 by 2 is 4, and 4 multiplied by 3.82 is giving me 15.28 cos A. Grouping these together, so I'm going to put these two now together. Don't put the minus 15.28 because it's stuck to the cos. So I have 4 is equal to 18.5924 is equal to, minus 15.28 cos A. I'm now going to move that 18.5924 over the equal sign. So it'll be 4 minus 18.5924 is equal to minus 15.28 cos of A. 4 take away 18.5924 is 14.59 is equal to negative 15.28 cos A. To get cos A on its own, I need to divide across by the minus 15.28. And when I divide that in, I get a positive 0.955. So I'm running out of space, so I'll just bring it up here to the right hand side. So 0.955. To get A on its own, I need to find the cos inverse of 0.955, which is 17.2538. And the question wants it to 2 decimal points, and the technical phrase for this angle is the angle OBC. So therefore angle OBC is equal to 17.25 degrees to 2 decimal places. The final part, part C. Find the angle BCA. Give a reason for your answer. So let me just draw out what we have here again. So I have my circle, and the 3 points in the circle that I'm going to focus in on is B, C, A. And they want me to find the angle BCA. So let me just mark that in green here. So that's the angle they want me to find. Now we know, let's fill in a little bit more information here. If I mark in my center point and I connect B to the center and A to the center, one of our rules tells us that the angle at the center is going to be twice the size of the angle at the edge of the circle when they sit on the same, the 3 points sit on the same arc. So let me just write in a little bit more there to explain that. We know that this angle here is 96 degrees. And our 3 points, B, A, and C, both of those angles, the 96 and the green one, are created by A and B, which sit on the same arc. So in order to find our angle, BCA, we take the 96 degrees and we divide it by 2 and we get 46 degrees. So that's the size of the angle that they're asking us to find. And give a reason for it. Well, I'm just going to state that the angle at the center is twice the size of the angle at the circle edge. But again, just maybe note that it must stand on the same arc. So what we mean by the arc, it's this here, the B to A. They're both standing on that same arc. Question 6a, part 1 and 2. The diagram below shows an isosceles triangle XYZ with WZ its axis of symmetry. The centroid, circumcenter and orthocenter are all on the line WZ. By using a ruler and compass, determine which point corresponds to which center. Mark each center in the correct box below. So we need our centroid, orthocenter and circumcenter. So you need to use your ruler and compass, as the question says, to construct those 3 constructions on the diagram below. Once you've them complete, I'm just going to mark up the answers here now for part 1, and you can also see my answer to part 2, which is constructing the in-center. ABCD is the parallelogram. The diagonals AC and DB are 10 centimeters and 6 centimeters in length respectively. So in the parallelogram, our diagonals will bisect each other, which means the sides are equal in length. So if A to C is 10, that means from A to O is 5 and O to C is also 5. If I come to the line DB, I have a length of 6 centimeters, so that means that D to O is 3 and O to B is also 3. More information we know is that COB is theta, so that's that angle in here. And I'm just going to fill in DOC, which is 180 minus theta. And that makes sense because it's a straight line there. So if theta was 60, the other angle would be 180 take 60. And it also tells us then that the area of the parallelogram is 26 degrees, or 26 centimeters squared. Find the size of the acute angle theta. Now, in order to find that angle, I'm going to look at the area of the parallelogram. So the key to this question is looking at the area of the parallelogram. Now, I don't know the lengths of the sides of the parallelogram, but I do see that it's made up of 4 triangles. So what I'm going to do is find the areas of these triangles. And the first one I'm going to find is the area of this triangle here. And the formula for my area of a triangle, so this is we'll call triangle 1, is given by half AB sine C. That's the area of a triangle. Now it's not half the base by the perpendicular height because we don't know the perpendicular height. Filling in everything I know there, it's half AB, which is my 2 sides, so that's going to be 3 and 5, multiplied by sine C, C being my angle theta between the 2 sides 3 and 5. And again, what would that give me? That would give me half of 15. But look at it, I have 2 of these triangles. I have another one over here. So what I'm going to do here is I'm actually going to multiply this answer by 2 because I have 2 of these triangles. So that's going to give me a total area for half of the shape, or those 2 triangles, of 15 sine theta. So that's the area of the 2 little triangles there marked 1 and 1. I'm then going to come over to the triangle 2 and 2. So I have 2 of these identical triangles. Let's find the area of that triangle. Again, I'm going to use my half AB sine C. I have my A and my B as my 2 sides, which creates the angle then, which is going to be sine of 180 minus theta. Again, though, I have 2 of these, so I'm going to times this by 2, which is giving me a total area there of 15 times sine 180 minus theta. So like I said at the start, we know that those 4 triangles add together to make the full area of the parallelogram. So if I add my 2 areas here, 15 sine theta plus 15 sine 180 minus theta, I get 26 centimeters squared. So I'm letting that equal to 26. The next thing I'm going to do here is I'm going to see if I can factorize out anything, and I can factorize out to 15 here. So I'm going to go 15 times sine of theta plus sine of 180 minus theta. So I've factorized out the 15 there, but it's still equal to 26. I'm going to divide across by that 15. So I get sine theta plus sine 180 minus theta is equal to 26 over 15. What else can I do? I'm going to go to my log tables now. And from page 14 in my log tables, I can rearrange this. See this part here, sine 180 minus theta. I'm going to change that. That is the same as me going sine 180 times cos theta minus cos 180 sine theta. So that's coming from page 14 in my log tables. And don't forget though, I have this sine theta to the front, so I need to keep that there. So that's sine theta plus the following. And again, equals to 26 over 15. I'm going to tidy that up now. I have sine of 180 on my calculator. That's giving me 0. So that's going to give me 0 multiplied by cos of theta. And then I'm going to put back in my minus here. And when I evaluate cos 180 on my calculator, I get minus 1. And then I'm multiplying that by sine theta. And again, equals to 26 over 15. And again, put back in my sine theta there to the front. Tidying this up now, if I multiply 0 by cos theta, that's just going to give me 0. Plus my sine theta to the front. 2 negatives give me a plus, and 1 multiplied by sine theta gives me sine theta. So you can see here, it's really starting to tidy up a little bit. I can group these. I have a sine theta plus a sine theta, which gives me 2 sine theta equals 26 over 15. To get sine theta on its own, I just divide across by 2. So sine theta is equal to 26 over 15 divided by 2, which would give me 13 over 5. So sine theta is equal to 13 over 15. And my final step is I need to get theta on its own. So I need to move over my sine. So it'll become sine inverse of 13/15, which is giving me a size of theta of 60.074 degrees. And it says, I think, to the nearest degree. So that's going to give me 60 degrees. Okay, so not the worst question when you kind of get into it a little bit. I'll just zoom out here so you can see it all together. Section B, the long questions. Question 7a, the mean percentage mark for candidates in the 2019 Leaving Cert Higher Level Maths examination was 63.3%, with the standard deviation of 16.4. The suggestion that candidates who appeal the results have, on average, similar results to all other candidates is being investigated. A random sample of candidates who appeal is taken. The mean percentage mark of this sample is 67.5%. Show that if the sample size was 25, then this result is not significant at the 5% level. So this is similar to a hypothesis testing, basically. I'm going to page 35 in my log tables and I'm using my z-score. So my z-score for my log tables is given as z is equal to x minus mu over standard deviation divided by n, the square root of n. So just to explain what these are, the x is standing for the sample mean, the mu or the u is standing for the population mean, the sigma symbol is your standard deviation, and n is the number of students. And z then is my z-score. So filling this in, I get z is equal to x, which is my sample mean, which is 67.5%. Subtract my mu, which is my population mean, 63.3%. I'm dividing that by my standard deviation, which is 16.4, over my square root of n, which is 25, square root of 25. And when I evaluate that on my calculator, I get a z-score of 1.28049. And I'm just going to make my conclusion now. So it's not significant at 5% since my z-score is between negative 1.96 and positive 1.96. So if your z-score falls between negative 1.96 and positive 1.96, then your result is not significant. So I'm basically agreeing that it is similar results here. Part B to that question is very similar. Show that the sample size was, if the sample size was 100, then it would be significant at 5%. But it's basically the exact same question here. So z is equal to x minus mu over standard deviation divided by the square root of n. Everything is just going to be the same except for my number of students. So my sample mean is 67.5, subtract my population mean, 63.3, divide by 16.4, which is my standard deviation, over the square root of n, which is now going to be 100. Putting that in my calculator, I get a z-score of 2.56. And now it's slightly different. So since my z-score of 2.56 is greater than 1.96, then the result is significant. So in other words, we can basically reject the claim that results are similar. Okay, so that's the first two parts done. Part 3, find the smallest sample size for which this result could be regarded as significant at 5% level. Again, we're using the same information here. We're using our x minus mu, my z-scores, over standard deviation divided by the square root of n, and I'm looking for my z-score to be greater than 1.96 because I'm looking for a significant result. And filling everything in as per before, 67.5 subtract 63.3 over my standard deviation, which is 16.4, divided by the square root of n. This is what I'm trying to solve now in this question. I'm trying to solve for n, but I'm going to let that equal to 1.96. And I have a fraction equals to a number, so I'm going to put this 1.96 over 1. I'm going to solve it then by cross multiplying here. Again, common denominators, but cross multiplying is a little bit quicker. So that's giving me 67.5, or actually I'll subtract these now. 67.5 subtract 63.3 is giving me 4.2 multiplied by 1 is equal to 1.96 multiplied by 16.4 over the square root of n. And I'll tidy that up a little bit. 4.2 by 1 is 4.2 is equal to, now I'm just going to multiply in this 1.96 into the bracket. So again, this is over 1, so multiplying fractions, top by top, bottom by bottom. So 1.96 by 16.4 is giving me 32.144 over the square root of n. I'm going to do the same principle steps again. Put this over 1, make a fraction out of it, cross multiply. So that's giving me 4.2 square root n is equal to 1 multiplied by 32.144. To get square root of n on its own, I'm going to divide across by 4.22. Or sorry, just 4.2. So the square root of n is equal to 2.653 is what I'm getting out. And then to get n on its own, I need to square both sides. So that's squaring a square root will get rid of it. So that's giving me n is equal to 2.653 squared. Apologies, that's a 7.653. My fault there. Just change that to, I'm doing my calculator wrong there. That's a 7.653. And squaring 7.653 will get me 58.568. And the question wants us to find the smallest sample size. So therefore my smallest sample size would give me n as equal to 59 people. Part B, only 389 candidates at the 220 Leaving Cert Higher Level Maths paper. A total of 275 candidates achieved a mark over 50%. A student claims that this result is not in line with previous years and finds that 78.4% of candidates achieved a mark of 50% in 2019. Assuming that marks are normally distributed, test the hypothesis that at a 5% level of significance, the percentage of candidates achieving over 50% had not changed from 2019 to 2020. State the null and your alternative and also give your conclusion. Okay, so it's heavy with text there, but it's basically asking us to do a hypothesis testing. So to do your hypothesis testing, the first thing you need to do is state your H0, your null hypothesis. And my null hypothesis here is that the percentage of candidates achieving over 50% is 78.4. That's the claim by the student in the question. Okay, and my H1, my alternative hypothesis is basically going to be the opposite of that. So I'm going to state the percentage of candidates achieving over 50% is not 78.4%. It's something other than 78.4%. Is not 78.4%. Okay, so that's my null hypothesis and my alternative hypothesis complete. Now I need to do my test. So I'm going to do a 95% confidence interval for the population proportion. That's what I'm going to do. And the formula here I'm using is my P plus or minus 1.96 times the square root of my P, which is my probability basically of 1 minus P over N. So that's the formula I'm going to use. In order to get P, I'm going to get the probability of picking that student. So what is it? It's 275 of them achieved over 50% out of 389 of them. So that's giving me a population proportion of 0.707. Now filling all that into my formula. So that's my little bit of rough work there. I have P, which is 0.707 plus or minus 1.96 times the square root of 0.707 times 1 minus 0.707 all over my 389 students. That's my size of my sample, my N. So that's giving me 0.707 plus or minus 0.045. Writing down my interval, so I add and subtract the 0.045, so that's giving me 0.662 up to 0.752. Okay, so that's my work done basically. Now I need to get to the final step, which is my conclusion, and just make sure when you're making your conclusion that you contextualize it. So it has to make reference to the subject in the question. So my conclusion here is that since my value for P falls between my intervals, it falls outside my interval. The student's claim of 78.4%, it falls outside my interval. My interval is going from 66.2% to 75.2%. So the student's claim is outside of that interval. So that means I'm going to reject the claim that the percentage of students receiving over 50% is 78.4% in favor of my alternative hypothesis. So let me just write that down. So there's my conclusion. So I'll state it again. Since 78.4% falls outside my interval is 66 to 75%, we are rejecting the null hypothesis in favor of the alternative, such that the percentage of candidates achieving over 50% is not in line with other years. And finally, part C. The graph below shows the distribution of the 2020 examination results by grade. Describe the shape of this distribution and comment on the standard deviation compared to the 2019 examination results, which were normally distributed. Normally distributed means it's in that bell curve effect. So it's quite clear to see here from this picture that it is not normally distributed. Okay, so normally distributed would look something like this. It has that bell curve effect, which this doesn't. It's starts high, goes down, and goes back up, and then goes back down. In other words, we could also say it's slightly positive skewed. We could also say that. Or another way of saying positive skewed is skewed right. It's tailing off to the right. And we could also say, what else could we say? We could say, I'm observing that most grades are weighted to the right. So if we look at the picture there's an awful lot of H3s, 2s and 4s, aren't there? So it's most grades are weighed slightly to the right, which would basically mean, so the standard deviation would be higher than the previous year. Okay, so my standard deviation here would be higher because most of my data seems to be around H5s, 4s, 3s and 2s. I think that's enough information to state there. Question 8a, show that the maximum height of the centre of a passenger capsule reaches above ground level is 165 meters. So the first thing there we're going to mark in is the diameter of the wheel, which is 150 meters. So I'm just going to draw that in red. So that's the diameter of my wheel. The next part says that the centre of each capsule is 4 meters from this external diameter. So if we mark that in, so the capsule comes down and it's 4 meters from the edge of the capsule. So that's from here to the center of the capsule is 4 meters, and I have my 150 meters from the diameter. I'm going to mark that capsule at the top as well. Again, going 4 meters to its center. It then tells us that the center of the passenger capsule is 7 meters above ground level. So we need to measure 7 meters again from the center of my capsule to ground level. So that's in green there. So I basically just need to add up all of those lengths. So I have 4 meters at the top. I have the 150 meters from my diameter. I have the 4 meters to the center of the capsule, and I have my 7 meters to ground level. Adding them together, I get 165 meters. Part B, find the time required for the wheel to complete one full revolution. Give your answer correct to the nearest meter. So revolution is one complete circle, and it's talking about time. So I'm going to draw out my time, distance and speed triangle. So I have distance, speed and time. The question here is asking us to find time, and the time is found by dividing the distance by the speed. Now, from the question, we know what the speed is. The speed is 0.24 meters per second. So we know that part, but we need to go off and find the distance of the full revolution. And the distance is basically the same as the circumference of the circle. And the formula for the circumference of a circle is given by 2 pi r from our log tables. And we know the radius of this wheel, it's going to be 75 meters, because remember it tells us in the question that the diameter of the wheel is 150 meters. So that's giving me a revolution or circumference of 150 pi meters. So bringing that back to my formula now and filling it in, I have time is equal to distance, which is 150 pi, divided by 0.24, which is seconds per minute, or meters per second, I should say. And when I divide 150 pi by 0.24, I get 1963.495. And that's giving us it in seconds, because don't forget the speed of it is given in meters per second. And the question wants it in minutes, so I'm going to divide this by 60 to turn it into minutes, which is giving me 32.725. Minutes, and the question wants it to the nearest minute, so therefore it is 33 minutes to complete a full revolution. Part C, the height of the centre of a passenger capsule above ground level was modelled using the following function. C, part 1, find the range of the function. So the range is basically from the top to the bottom. So if I sketch this out very roughly here on an XY graph, just so we can visualize the cost function, we know that the 86 here in front of it, the scale factor here, this 86 is telling me where I go up and down on my y-axis. So I'm just going to mark in that 86 first of all onto my y-axis. And it then tells us the amplitude. This 75 in front of the cost tells us the amplitude, basically how far up or down it goes from this center point, this point here of 86. So I need to basically go up 75, and I also need to come down 75. That's what that 75 represents, the amplitude. And when I add 75 onto the 86, that's bringing me up to a height of 161. And when I go down 75 from 86, that's bringing me to a lowest point of 11. So therefore, my range is going to be between 11 and 161. Part 2, complete the table below to show the height of the centre of a passenger capsule above ground level for the time period shown, correct to the nearest whole number. So basically what we're doing here is we're subbing in these values for time in for t into our function. So I'm just going to write out maybe the first one there for us. So if I was doing, or let's pick a different one. Imagine I was filling in this one for number 30, when time is at 30 minutes. I would go on my calculator 86 minus 75 multiplied by cos at 2 pi over 33 times by 30. And just make sure if you're using your calculator here that your calculator is set in radians mode, because it involves using pi. So I'm going to just do those out in my calculator, and I got 11.55, and you can see there the 11 is my lowest point on my range in part 1. 135, 158, again these are all to the nearest meter, 97, 23 and 23 again for 36. Okay, not too difficult there. And the final part, part 3 to that, is to draw the graph to show the height of the centre of the passenger capsule above ground level for 2 complete rotations. So again, I just need to plot those points. So it's going to go t followed by h. So 0 on time up to 11 would bring me to, so actually looking at our y-axis, look at the way it's done. It's height in meters, and it goes 5, 10, 15, 20. Now, our passenger capsule goes up to 160 meters. So I'm actually going to adjust our axes here, and I'm just going to go with a little multiply by 100 here. So basically, if I multiply by 10, I should say. If I multiply 5 by 10, I get 50 meters. 10 by 10, I get 100 meters. And that'll become 150 meters. And then finally 200 meters. So I just need to adjust my scale here. And now I'll plot the points. So I need to go 0, 11. So it's going up in 10. So 11 is probably about here. My next point is 655. Again, it's going up in 10. So halfway between the dots here. So that would bring me to around here. Okay, so there's my points, and my final point is 3623. And I now have to do a freehand curve that goes through all of those points. Which would look something like that. And my top one there just didn't touch it. So freehand looks something like that. Part IV, the most spectacular views of the city can be seen when the height of the centre of the capsule exceeds 100 meters above ground level. So we need to be above 100 meters. Using your graph, estimate the length of time during the ride for which these views are possible. So I'm looking for everything above 100 meters. So if I come back up to my graph here for a second, and I am looking for above 100 meters, I'm actually just going to draw a line across here at 100 meters. So there's my 100 meter mark. And I'm then just going to drop a dotted line down to my x-axis, or my times, which will give me the times basically. So I need that time, and I also need this time here. So I have at 24 minutes, and I have just before 12, it's going up in threes. So what's that looking like? Maybe about 10 minutes, give or take. So it's basically between 10 minutes and 24 minutes into the ride. So I'm going to go from 24 minutes, subtract 10 minutes. So it will be above 100 meters for approximately 14 minutes. Part V. Calculate the rate of change of the centre of the capsule 12 minutes after the start of the ride. Give your answer in meters per minute, corrected 2 decimal points. So just going back to the start of the question here, my function is h of t, height, which is 86 minus 75 cos 2 pi over 33 times t. Rate of change, hopefully we remember, is got to do with calculus, differentiation in particular. So I basically just need to differentiate my function and then sub in 12 for t. So if I differentiate my function here, I'm going to get h dash of t is equal to, well, 86 will just drop off. So differentiating a constant, it's just going. Now I just need to differentiate this part here. So I'm going to come over here and do a little bit of rough work. So I want to differentiate minus 75 cos 2 pi over 33 times t. So this is what I want to differentiate. And I'm going to differentiate it using the chain rule. And I'm going to let u is equal to 2 pi over 33t. So that's what I'm going to sub in for u. So I need to therefore differentiate minus 75 cos of u. So that's the first thing I need to differentiate. And then I'm going to come over and I'm going to have to differentiate my u, which is 2 pi over 33t. Differentiating the first part, let's just give this a name. I'm going to give it the function y. So differentiating y, so that'll be dy du, is equal to, well, differentiating cos becomes minus sine. So I have a negative from the question and I have a negative from the derivative. So that becomes a double negative. Sorry, I forgot my 75 there as well. So minus 75 sine of u. The two negatives will become a plus. So 75 sine u. And then differentiating u with respect to t. So du dt will just give me 2 pi over 33. I now need to put them back together. So the chain rule tells me to multiply them by each other. So therefore I get 75 sine of u times 2 pi over 33. And don't forget at this stage to sub back in your value for u. So it's 75 sine of u, which is 2 pi over 33t, and multiply that by 2 pi over 33. So that's my derivative. So coming back over and filling that in, h dash of t is equal to 75 sine of 2 pi over 33t multiplied by 2 pi over 33. And that's my derivative. Now we need to solve it when t is equal to 12. So I'm basically finding h of 12, and that's going to give me 75 times sine of 2 pi over 33, subbing in my t now, which is 12. And that's all going to be multiplied by 2 pi over 33. Just again, make sure that your calculator is set in radians mode at this stage. So that's giving me a value of 10.79208 when I do it out in my calculator. Question wants it to 2 decimal points. So therefore, calculate the rate of change. It's giving me to 2 decimals, 10.79 meters per minute. Question 9. The net of a hexagonal prism is shown. A cosmetics company plans to use a box made from this design to package a new fragrance. The base of the box is a rectangular hexagon of side 4 centimeters. Part A, find the area of the hexagon base. Give your answer in third form. So we're basically looking for the area of this shape here. That's what we're trying to get the area of. And if we think about it here, it says that the sides are 4 centimeters in length. So let's just mark up our picture here as best we can. So all of these lengths are 4. And if I break the shape up into triangles, so imagine the center point here of this hexagonal, and I'm going to connect that center to each of the corners here. So I'm making triangles out of them. And I've now made 6 triangles, and each of these angles are going to equal in size. So they must all add up to 360. So if I divide 360 by 6, I'll get 60 degrees. So each angle is 60 degrees in length. I can also say that each of these triangles is a right-angled triangle, or not a right-angled triangle, an equilateral triangle of each angle being 60 degrees. So if we focus in on one of those particular triangles in a little bit more detail, so let's just sketch it out here. So I have my triangle, I have my angle of 60 degrees, and my 2 sides here I can label as 4 and 4. Well, all of them are 4, all of them are 60. And I'm asked to get the area of this shape. So if I get the area of one of these triangles, so area is equal to, well, I can't use half the base by the perpendicular height. We can go off and use Pythagoras to get the perpendicular height. It's just easier maybe to use half AB sine C for this particular question. And that'll give me half times 4 times 4 times 60. And that'll give me the area of one of the triangles. So that's getting me 4 root 3 for one of them. Now we have 6 of these triangles, so therefore total area will be 4 root 3 times 6, which is 24 root 3 centimeters squared. That's the area of the base of the box. Looking at part B, the bottle for the fragrance is in the shape of a cone, the base of which fits exactly into the box as shown. Find the radius of the base of the bottle. So the bottle has a circular base here. Again, I'm going to focus in on just one of those triangles once again. So imagine our center point here. And if we look back on the hexagonal, if I draw a line out to that corner here, we know that that is 4 centimeters. And if I draw a line out to another corner of the hexagonal, that's also 4. Now what I'm going to do though is we're asked to get the radius of the circle. So if I draw my radius now, touching the edge of the circle, which also touches the edge of that triangle. Now that's creating 2 90-degree angles here if it's perpendicular to the side of the base. And again, because it's equilateral, I've now created 2 triangles of length 2 and 2. So again, I'm just focusing in on one of those triangles, say for instance this one here. So I'm going to sketch that out. So I have a triangle, 90-degree base of 2, side of 4, and we're trying to get the length of the radius. So here I can use Pythagoras theorem. So c squared is equal to a squared plus b squared. My c is always the hypotenuse, the side across from the 90 degree, and my a and my b, it doesn't matter which one you call a and which one you call b. So I'm getting 16 is equal to 4 plus r squared. Subtracting 4 from both sides will get me my radius squared. And that's giving me 12 is equal to r squared. So r is equal to the square root of 12, which is 2 root 3 centimeters. So that's the radius of the bottle that fits into the box. Scrolling down now to part C, the bottle is to contain 100 ml of perfume with an additional 5.5 centimeters cubed of space to allow for the nozzle. Calculate the height of the entire bottle. Give your answer correct to 1 decimal point. So let's look at the volume of this. It's the volume of a cone. So we have the volume of this fragrance, which is the volume of a cone, which is from my log tables 1/3 pi r squared h. And don't forget though, we have to add on 5.5 centimeters cubed to account for the nozzle at the top. Now, it's 100 milliliters in volume, so adding those two together will give me a volume of 105.5 centimeters cubed. That's going to be the volume of my shape. And again, the shape is a cone, so 1/3 pi r squared h. Now at this stage, if you're confused with adding the mils and the centimeters cubed, just remember that there's 1,000 centimeters cubed in 1,000 mil. So a liter contains 1,000 centimeters cubed. And we just need to solve this now for h. Well, we can actually fill in my radius. So it's 105.5 is equal to 1/3 pi, radius is 2 root 3. Squaring that and timesing it by h. That'll give me 105.5 is equal to multiplying the third by 2 root 3 squared gives me 4 pi h. And I want h on its own, so I'm dividing 105.5 by 4 pi. And when I divide that out, I'm getting 8.395 centimeters, and the question wants it to 1 decimal point, so that's giving me a height of 8.4 centimeters. Part D, the box is designed so that the bottle fits exactly and the trapezoidal flaps each have one parallel side, 1 centimeter shorter than the other and are of width 1 centimeter. Find the total area of the cardboard needed to make the box correct at 2 decimal points. Okay, so let's scroll back up and break our shape up into many different areas. So as we look at our shape, I'm going to first of all focus in here on the base, so this area here, and I'm also going to call it the lid, this area here. Now we have those areas, we got them from part A to be 24 root 3. That was part A, find the area of the base. So I'm going to first of all take those two areas, the base and the lid. So my base is 24 root 3 centimeters cubed. My lid is the exact same area, which is going to be 24 root 3 centimeters cubed. Sorry, I said squared, but it's centimeters cubed. So there's two areas found. Back up to my picture now, and the next area I'm going to find is the rectangular side. So this one, this one, this one, this one, this one, this one. So I have 6 of these rectangles. We know the dimensions of these. We know that it's 4 centimeters at the base. So we found that's given to us actually in the question. And we also know the height of each of these rectangles here. We know that that length is 8.4. And we found that 8.4 centimeters back in part C, the height of the bottle. So I basically just need to multiply 8.4 by 4 6 times. So I have my sides and I have 6 of them. And I'm going to multiply that by the area, which is 4 multiplied by 8.4. And that is giving me a total area for the sides of 201.6 centimeters cubed. Back up to the picture. Focusing in now on the flaps, the little sides, these little bits here. So I'm going to get the areas of this one, 2, 3, 4, 5, 6. So I have these 6 flaps. Again, the length of them is 8.4. That's the height of the bottle. And it says that it's 1 centimeter shorter at either end. So I'm going to take the average. So I'm going to go 7.4 plus 8.4 and divide that by 2. So I'm basically going to get the average length of each of these sides. And they also tell us then it's 1 centimeter thick. So they tell us that. So let's go down and multiply out those 6 times. So I'm going to call it 6 flaps, and I'll call them the vertical ones. As the box is full, they'd be the sides of the box. So let's multiply them out. So I have 6 flaps. I have an average length of 8.4 plus 7.4 because it tells us they're 1 centimeter shorter at either end. And I'm dividing that by 2 to get the average. So that's the length of the flap. And then I have to multiply that by 1 because that's the thickness. So don't forget the formula for the area of a rectangle is length by width. So multiplying that out, I'm getting 47.4 centimeters cubed. And I have one area that I still haven't found. And if I mark them on my picture here, it's these flaps. 1, 2, 3, 4, 5 of these. Again, the width of these, or the length of them, the total length of the side is 4. We need to add 3 to that because remember that this here is 1 centimeter long and I have 2 of them at either end, 2 triangles. So rather than take away the triangles, if I go 4 plus 3 divided by 2, so get the average length of that side to be 3.5, multiplied by its thickness, which is 1 centimeter, and then multiplied by 5 because I have 5 of them. So let's call this 5 flaps, and I'll call them the horizontal ones. They're the ones going across the face of the box. And I have 5 of these. The total length is 4, but we take away the little triangular end. So an average length of 4 plus 3, sorry, that's a plus there. 4 plus 3 is 7, divided by 2, multiplied by 5. And the thickness of them is 1, which is giving me 17.5 centimeters cubed. And the question wants me to get the total area. So I need to now add this length, this length, this length, this length, and this length together, the total areas. And when I add them together, I get 349.638 centimeters. Sorry, I've been calling these cubes the whole way down. My fault. It's not volume we're doing, it's squared, it's area, my fault. Just change all of those to a square. And that's giving me, the question wants it to 2 decimal points. So 349.64 centimeters squared finally. Okay, part E. Part E seems to be like you're linking part C and D again together to make one part. So if a taller promotional bottle of perfume were to contain 150 milliliters of fragrance, calculate the percentage increase in the amount of cardboard needed to produce the box. So first of all, we need to get the height of this new box. And remember from part C, so I'm just going to do it out here. From part C, we got the volume of the box be 105.5 centimeters cubed, because don't forget we needed to add on that 5.5 centimeters cubed for the nozzle. And it's now increasing it to 155 milliliters. So I need to go 150 plus, or sorry, it's increased to 150 milliliters. So I need to increase 150 plus the 5.5 for the nozzle at the top. So don't forget to add the nozzle to this total volume here. And once again, that's going to equal to the volume of the shape, which is a cone. So 1/3 pi r squared h. So what I'm trying to do here is I'm trying to get the height of this new bottle. And if I tidy that up a little bit, it'll become 155.5 is equal to 1/3 pi. Radius doesn't change, 2√3 squared h. And that's giving me 155.5 is equal to 4 pi h. And then to get h on its own, it's 155.5 divided by 4 pi, which is giving me 12.37 centimeters. So that's the height of the new box, or the new bottle. So, like I said, I now need to come back over and find the area of the box, exactly like part D, except we're using these new dimensions now. So I'm going through all the motions again. So let's start with the base. And the base is the same as part A, which was 24 root 3. Again, we have that up in part D. The top, or the lid of the box, again, is going to be the same area from part A, which is again 24 root 3 centimeters squared. I'm then going to do my 6 rectangular sides. So I have 6 of them. The area of them now is what I need to find. So the width is still 4, but the height has now changed. The height is no longer 8.4, it's now going to be 12.37. So that's the only difference really. And when I multiply 6 by this area, I'm getting 296.88. I'm then going to focus in on the 6, again, I'll call them vertical flaps, the little sides, and once again, 6 of them multiplied by the new length. Now it's not going to be 8.4, it's now 12.37 plus 11.37, because again, remember that there's 1 centimeter triangles cut off each length. So I'm getting the average of those two lengths, so divide by 2, and I need to multiply that by the width, which is 1 centimeter. And that's giving me 71.22. And finally, I need to do my 5 horizontal flaps. I think these were the ones that we marked in purple back at the original part D. And this again is going to be 5 of them, multiplied by their average length, which is 3 plus 4, divided by 2. And this is the same area actually that we got in part D. And the width of them 1 centimeter. So that's giving me an area of 17.5. So look at the main one that changed here was really just this one and this one, to account for my new height of the box here, the 12.37 and the 12.37. In the previous part D, they were the 8.4. Okay, and we now have to add them together. So the areas I'm adding together is this one, this one, this one, this one, and this one. So my new volume of the box is 468.738. The question doesn't want the new area or the new volume of the box, or new area I should say. It's looking for the percentage difference between the old and the new. And the formula that I use for the percentage difference is going to be the difference in their area over the original area. And I times that by 100 over 1 to get my percentage. So my difference is going to be 468.738, subtract my answer from part D, which is 349.64, divide that by the original area, again, the answer from part D, and I multiply that by 100 over 1, which is giving me 34.06%. So that's the percentage difference in the areas from the old and new. Question 10a, part 1. One particular model, made by Pope Manufacturing Company in 1886, weighs 36 pounds, has a 60-spoke 130 centimetre diameter front wheel and a 20-spoke 46 centimetre diameter rear wheel. Find the circumference of the front wheel in terms of pi. So it tells us here that the front wheel has a diameter of 130 centimeters, so that means it has a radius of 65 centimeters. So we'll just divide 130 by 2 to get the radius, which is 65 centimeters. The formula for the circumference of a circle is given in our log tables as 2 pi r. So filling in my formula is giving me a circumference of 2 multiplied by pi multiplied by my radius, which is 65, which brings me back to the 130. So the circumference here in terms of pi is given as 130 pi centimeters. Part 2. If a cyclist pedals the bicycle such that the front wheel rotates at 2 revolutions per second, Calculate the speed of the cyclist in meters per second. Give your answer to 2 decimals. Revolution is just a complete circle of the wheel. It's talking about calculating the speed. So I'm going to go to my distance, speed, and time triangle. And it's asking us, as I said, to get speed. So speed is given as distance over time. Filling in my distance, it's going to be, well, 1 revolution is 130 pi. I'm going to times that by 2 because I'm doing 2 revolutions. And my time is 1 second because it's given in meters per second. So that's just simply giving me 260 pi centimeters per second. Now the question wants it in meters per second, so I need to divide this by 100 because there's 100 centimeters in 1 meter. So that's giving me 2.6 pi meters per second. And it wants it in decimals, so it's because it says to 2 decimal points, so that's getting 8.17 meters per second. Looking now at part 3, the rear wheel travels at the same speed as the rest of the bicycle, but it rotates faster. Find, correct to 2 decimal places, the number of revolutions per second at which the rear wheel rotates. So let's first of all find the circumference of this rear wheel. So the circumference, again, the formula for my log tables is 2 pi r, C for circumference. Filling that in, I get 2 multiplied by pi multiplied by the radius. Well, if you scroll back up to the top of the question, it tells us that the diameter of the rear wheel is 46 centimeters. So if I divide that by 2, I get the radius, and the radius there would be 23. So I'm subbing in 23 for r, the radius. And again, when I multiply 2 by 23, it just brings me back to the diameter. So you could use the formula just diameter times pi, but that's bringing me to 46 pi centimeters. So that's the circumference of that rear wheel. Now the distance that that rear wheel has to travel is the same as up above. It's this here. So it's still 2.6 pi or 260 pi centimeters. And I'm just going to divide that then by the 46 pi because that'll find out how many of the 46 pi's, that small circle, is in the bigger circle. And when I divide that in, the pi's will cancel, so that's getting 5.65. So the number of revolutions needed is 5.65. I don't need to do my distance, speed and time formula there again, because it's still just time as 1 second. B part 1. A penny farthing with a back wheel of diameter 50 centimeters is standing on horizontal ground and is leaning against a vertical wall. The front wheel is standing against a supporting rectangular wooden block of height 30 centimeters and width 15 centimeters. Use Pythagoras' theorem, or otherwise find the diameter of the front wheel. I am going to use Pythagoras' theorem, which is given as c squared is equal to a squared plus b squared. Let's try and find our C, A and B here. So they've kind of given us this little triangle here to help us. So I just need to mark in some of the lengths. This red line here that I'm drawing from the center of the wheel down to the edge is known as my radius. So I have this dotted line in full length as r. But we know that this little part, this length, is the same as the thickness of the block. And the thickness of the block is this 30. So to get just this little part that I'm marking in green here, it's going to be whatever the radius is and subtract 30 from it. So that's what I'm going to write here. So it's going to be 30 taken away from r. So that's just going to give me the length of that green line. And it's going to be the same here. If I have this length here, this is my radius length, I'm then subtracting away this 15 here from the radius. So I'm taking away a 15, which is basically the same as this length along here, that line here. So that's going to be the radius take away 15. So I'm just going to mark that in as r minus 15. So the length of that red line is r minus 15. And my final line that I'm going to mark in here in blue is from the center out to the edge of the circle, and that's going to be my radius. So if I sketch that triangle out a little bit neater, I have a right angle triangle. I have my hypotenuse as r. I have the base of it here, or minus 15, and the side of it, or minus 30. Filling that into my Pythagoras theorem, my C is going to be or, so that's or squared. A and B, it doesn't matter which one you call A and which one you call B. I'm going to go or minus 30 as A, plus or minus 15 squared as B. Multiplying out my brackets here now, so it's squared, so I have to times them by themselves, plus my or minus 15 by or minus 15, which is going to give me or squared is equal to first term by second bracket, second term by second bracket, and then I'm coming to the last two brackets, so it's or multiplied by or minus 15, and then minus 15 multiplied by or minus 15. Multiplying all this in, I'm going to get or multiplied by or multiplied by 30, and then the 30 by this second bracket here, so that's going to give me or squared minus 30 or minus 30 or, and then minus 30 by minus 30 is plus 900. Coming to the last two, I'm multiplying in this or now here, which is going to give me or by or, which is or squared, minus 15 or, and minus 15 by minus 15 will give me a plus 225. Tidying all this up, I'm going to subtract or squared from both sides, or basically just move this over here so I can have it equal to 0. So it will be, let me just put that in a different color now when I bring it over, but tidying all this up, I'm going to put my ors together here, so I have all of these ones that I can group. So they're going to give me minus 90 or. I'm going to look at my or squared now, so I have an or squared here, that's 2 or squared. And my constants, 900 plus 225 is giving me plus 1125. Don't forget though, I moved over that or squared, so I need to go minus or squared. That's this one here. So, final line there will give me 2 or squared minus or squared, which will be 1 or squared, minus 90 or plus 1125, and that's equal to 0. I need to factorize that now because I need to solve for or, so I'm just going to bring it up here. Or squared minus 90 or plus 1125 is equal to 0. The factors here to get to multiply to 1125 and add to 90 are 75 by 15. So or 75 multiplied by 15, two minuses will multiply to a plus, and 75 minus 15 will give me minus 90. So solving both of those for or, that'll give me or is equal to 75 and or is equal to positive 15. So it wants us to use Pythagoras' theorem to find the diameter of the wheel. So therefore the diameter of my wheel is going to be well, a radius of 75. I can't take this smaller length of 15. Just look at your diagram. 15 centimeters won't work there because don't forget the block is 30 centimeters thick. So it has to be greater than 30. So I'm taking my radius of 15. I'm going to times that by 2 to make it into diameter. So that's 150 centimeters. So that is the length of my diameter. Looking now at part 2, the distance between the two wheels along the line joining their centers is 10 centimeters as shown. Find the distance between the centers of the two wheels in meters. Okay, so let's just clear up our picture here and let's mark what we have. So I need the length of that green line basically. Not too difficult. We have a radius now, which is 75. I found that from part 1. I have the 10 here, which is the difference between, or the thickness between the two wheels. And then what about the radius of this smaller back wheel? Do we know anything about it? If you go back up to the question here, it tells us that the back wheel of diameter 50 centimeters. So 50 divided by 2 would give me a radius of 25. So I basically just need to add those three lengths together. So therefore 75 plus 10 plus 25 will give me a total length of 110 centimeters. The question wants it in meters. So dividing by 100 to turn it into meters. So therefore it's 1.1 meters in length. So the final part 3, another rectangular block of which 10 centimeters touches both the wall and the front wheel of the bike. Find the maximum height of the block of wood correct to the nearest centimeter. So I'm just sketching what that would look like. So I have my wall and my front wheel. I now have a block here that I'm going to just draw in. That's my timber block. And it's telling me that the width of that timber block is 10 centimeters in width. They want me to calculate the height of this block. Now we know all the same information as above. So I have, let's just draw in here. I have my line coming across here up to the center. I'm creating that same triangle as I did in part 1. I have my length r. This side now is no longer going to be r minus 30. It's going to be r minus h. I don't know what that distance from here to here is going to be, so I'm subtracting that h. The width along the bottom, I do know it's going to be r minus 10, so I'm subtracting the 10, the thickness of the block. Now I can change them though. I know that the radius of my circle is 75 centimeters. So I'm going to change this now to 75 minus h, because the r is 75. And same down the bottom here, I'm going to change it to 75 minus 10, which is the same as 65. And my r I'll change to 75. So I'm just going to sketch out that triangle a little bit neater now and fill in those lengths. So if I draw that out again, I have radius 75. I have the base here, which is r minus 10, 75 minus 10, which is 65, and the height here, 75 minus h, or r minus h. I'm going to use Pythagoras' theorem again to find h, so it's going to be c squared is equal to a squared plus b squared. Subbing in my c, which is 75, the hypotenuse, is equal to a, I'll call that 65, and b then is going to be the other side, 75 minus h, all to be squared. Tidying this up, 75 multiplied by 75 is 5625. 65 65s, 4,225. And then I need to multiply this bracket out by itself. Something like that. Tidying it up, 5625 is equal to 4225. Multiplying in these brackets now, I'm getting 75 by 75, which is 5625. 75 by h, and again h by 75, which give me minus 150h, and then h by h would give me a plus h squared. Okay, I'm going to move this 525 over and tidy it up. So that's going to equal to 0. So I have 4225 plus 5625 minus 150h plus h squared, and then I'm going to subtract that 5625, which came over the equal sign. So that's going to give me h squared minus 150h, and that's going to cancel with that. So that's just leaving me with plus 4225. So I need to go off basically and factorize this quadratic. Now it's telling me there it wants it to the nearest decimal or the nearest centimeter. So more than likely there I won't be able to do my two brackets to solve this. I'm going to need my minus b formula, so I'm just going to bring it down here to the extra space page. So h squared minus 150h plus 4225 equals 0. Going to my log tables and I'm taking my formula for the minus b, which is given as x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. My x in this question is going to be h. So that's going to be h is equal to minus b. So this is my a, this is my b, and this is my c. So minus 150 plus or minus the square root of b squared, again, minus 150 squared. Just make sure that goes into a bracket on your calculator because it won't do the two negatives. 4 times a, which is 1, times c, which is 4225. And that's in a square root all over 2 times a, 2 times 1. So I need to tidy all this up now a little bit more. So that's giving me h is equal to minus minus becomes plus, and my square root, when I work all that out, is giving me the square root of 5,600, and it's all over 2. So solving this, I get h is equal to 150 plus the square root of 5600 over 2, and h is equal to 150 minus the square root of 5,600 over 2. Working both of those out, I get h is equal to 112.42 centimeters, and I get a height of my block of 37.58 centimeters. Now I just need to decide on which one is going to be my answer. I'm going to ignore this one because this one is actually greater than my radius. So I'm just going to state that. Can't use since 112.42 is greater than my radius. And don't forget my radius of the wheel, was it something like 75 centimeters or something like that? So obviously the block can't be bigger than the radius. So therefore I'm taking H as 37.58. That's going to be the maximum height that the little timber block can be. If you have found these solutions to the mock papers of help to you, I'd be very grateful if you could subscribe to the Tullamaths YouTube channel.